physical and chemical changes of different substances. There are a lot of different substances in the world. We need to be able to figure out what we're looking at and how we can tell other people about it. So the first thing you do when you see something new is you take a look at it. Mr. Thompson, what do you see when you look at this?
Water.
How do you know it's water?
It's clear.
Okay.
It looks liquidy. It's kind of moving around a little bit.
Doesn't really smell like anything, which is good. However, never stick your nose in stuff like that. You'll regret it at some point this year, I promise. All right, so it looks clear, it looks colorless, it's liquid. These are all things we can see and experience about our substance. Those are all physical properties. They're things that you can just look at. As opposed to this, what do we see when we look at this?
Chunky stuff.
Chunky stuff.
It's all clear. It looks like it's kind of melting down the bottom.
So these are all physical properties. Things you can see and experience. Things being solid, things being liquid, what color they are. Here we're also seeing a physical change. We've got our ice and it's melting. And it always melts at a certain temperature, which is called our melting point, which is actually the same as our freezing point. There are a lot more physical properties that we can get into. Physical properties could be about something like this. What do you notice about this?
It's shiny.
It's shiny. The actual technical term for shiny is lustrous. It has luster. If I tried to run electrical current through it, would it work?
Well, it looks like a piece of metal, and I remember hearing that metal could have electricity go through it, so I would say yes.
All right, so conductivity, we could smash it with a hammer and it would actually just smash instead of breaking. Might not work, which is why we're not trying that here. Some of your physical properties are dependent on state. Like our liquid, we said, looked really liquidy. The fact that it moves around really easily, that's its viscosity. If it was something like honey, it would flow a lot less easily, and that would be a higher viscosity.
Now, I've got a question for you then. Is the stuff on the bottom, the liquidy stuff, is that the same as the solid stuff?
Right, because one of the definitions of a physical change is that it's still the same substance all the way through. It was frozen water and now it's liquid water. It's not going to change what we're looking at. So no matter what happens, if it's a physical change, it's still the same chemical composition. It's still H2O. So we could do all sorts of things to it, it would still be water.
Could we take the liquid water and turn it back into the solid water?
Right. Physical changes can be reversible. It could be something like water. It melts, you can freeze again. It'll be still water. However, is everything that's a physical change going to be reversible?
I don't know. I mean, I guess if it was a physical change, wouldn't it have to be? I mean, I can change that physically.
How can you change that physically? How about let's look at changing this physically? What's something we could do to this to change it physically? Is it still paper plate?
Yes.
It is still paper plate. We haven't changed it chemically. It's still paper. But can you put this back together again?
Yeah, give me a second.
Is it going to be exactly the same as it was before?
Well, I think I can. No, I don't think this will be exactly the same it was before.
So ripping something is a physical change. It's still a paper plate. We haven't changed that, but it can't be put back. So don't think physical change, you can reverse it, because that's not always the case. All right. So something else we can do that's a physical change is dissolving things. So I can take my salt and put it in water, and I swirl it around, and it's all eventually going to dissolve. Could I get that salt back?
Yes.
Think back to things we learned in the last video. What could you do to get that salt back?
Well, there was something if we evaporated the water.
If we evaporate our water off, then we will get our salt back. So that's how we know it's a physical change. You can get it back. Doesn't necessarily mean reversible, but it means the substances are still there. The salt is still in the water, and we can get that salt back because it's still salt. All right, so another thing to think back to middle school, and we talked about this a little bit already, what do we call the chunky bits? What kind of state are they in?
Solid.
Solid. And so they're mixed in with what right now?
Liquid.
So they're in different states, they're in different phases, and getting between them is what we call a phase change, or a change of state. That's where we have the same substance. What was water?
Hydrogen and oxygen.
Right, it's our H2O. And it's still H2O whether it's solid or liquid, or what would happen if we sat that on a stove and heated it up?
We would get our third phase, which is gas.
Gas. And what do we call when it goes from a liquid to a gas?
Evaporation.
Evaporation or boiling, depending on how fast it's happening. So we were just looking at our physical properties, right?
Yes.
Was just looking at things and seeing what it looked like terribly interesting?
Not terribly.
What did you get into chemistry thinking you were going to do?
Blow stuff up.
Blow stuff up. The ability to blow stuff up is an example of a chemical property. Chemical properties are how two substances interact. When you blow stuff up, something reacts with oxygen and goes boom, which is cool. That is one sign of a chemical change, but it's also a chemical property. They're really hard to separate out from each other, actually, because the only way you can tell if something has a certain chemical property is by observing its chemical changes. So one chemical change that we can observe is I will take this powder and I will mix it in with this water, and something cool will happen. See? I mix it together and it lights up.
You're right, that is cool.
So the production of light is one sign of a chemical change, but the fact that I mix this powder in water and it lights up is a chemical property. So if I do a chemical change, I have two new substances. I had water and this substance, and now I get something that lights up. I can do some other kinds of chemical reactions. So what do we know happens if I strike this match on this box?
The head of the match will catch on fire.
Head of the match will catch on fire. The ability to catch fire is a chemical property. When I actually strike it on the box, that's a chemical change. So there are some other signs of chemical reactions we can have. And one of them's going to have to wait a second. We can do the old household standby and mix vinegar and baking soda. If I put vinegar in here, and some baking soda, which you just find around your house.
No.
So we get another reaction.
Bubbles.
More bubbles. Are bubbles always a sign of a chemical reaction? If you take a straw and you blow on your soda, do you get bubbles there?
Yeah.
Has a chemical change happened?
You're not really changing the soda.
Right, you're just adding more bubbles by blowing into it. That's not a chemical change. Bubbles are usually a sign of a chemical change, not always that reliable.
So maybe if you put two things together?
If you mix two things together and it makes bubbles, there's your chemical change. All right, so we've just put magnesium ribbon in this test tube, and I've got a pipette here that's full of hydrochloric acid. So we can do another chemical reaction. I need you to actually hold on to this. So hang on to this, do not do anything, hold the pipette too. Don't do anything until I tell you. All right, so this should make hydrogen gas, and hydrogen gas is flammable. So this will do something else cool with the wood split, but I need to make sure it's ready. All right, so making hydrogen gas, we're trying to prove it. There we go.
So let me make sure I have this straight. Physical properties. That's describing what it looks like, things like that, things that we can observe. We can do physical changes where we're changing, like with the water, we change what it looks like, but it was all still water. Okay, and we can sometimes go backwards, take the liquid water and refreeze it, but with the paper plate, I couldn't put it back together.
It's still a physical change because it's still a paper plate. It's just a torn paper plate. It looks a little bit different.
Okay, so then chemical changes then, that's talking about how things react with each other. So lighting the match is the chemical change.
Because the matches have the chemical property of being able to catch on fire.
Okay. And then how we can tell is if we have a chemical change. Bubbles.
Bubbles were usually a good one. If you're mixing two things together, you get bubbles.
The change in color. We got the glowing stuff. That was pretty neat.
Fire, also really good sign of a chemical change. And so light being produced, like in the glowing thing.
Right, and with the fire. Awesome.